Hello and welcome, my dear grade 10 elite students, to today's session, which is specially for your coming term 3 math exam. Today in this video, we are covering learning objective 4 and this is from part 1. The learning objective is to integrate functions by using substitution. So let's get started for the video and see how to solve questions 3 to 6. The method that I'm going to be using for solving this question is integration by substitution. And these are questions 3 to 6 on your math book, page 213. So let's get started with the solution. All of them are going to be using the same method of substitution, but we are going to substitute different things. So let's see how we solve question number 3. Here we are going to substitute a new variable u, which will be the value x cubed plus 2. So when I do that and I differentiate both sides with respect to x, I get du over dx as I apply the power rule for derivatives. So the power reduces, 3 comes down, reduces by 1, and the derivative of a constant is 0. So from here I get dx as du over 3x square. So this is now what I'm going to substitute back here. So this integral, which was given originally, changes to x square, square root of u, and in place of dx, I put du over 3x square. So this is the new integrand, and your dx has already changed to du now. So we have used integration by substitution by replacing the variable x, which was there originally, with the variable u. Now x square and x square is going to cancel. This 1 by 3 is going to come out of the integrand, and inside you are left with u to the power 1 by 2 du. Now you can apply the power rule for integral as we did in the last video. So the power is going to increase by 1 and we are going to divide by 1 by 2 plus 1. Always remember to also add the constant of integration. So the denominator 1 by 2 plus 1 changes to 1 by 3, and that comes out of the integral. So this becomes finally 1 by 3 multiplied with 3 by 2 over u to the power becomes 3 by 2 plus c. Now here the denominator 3 by 2 would be in the reciprocal. So in the next step we are going to change the reciprocal. So this becomes 2 over 9 u to the power 3 by 2 plus c. Now to give the final answer, we have to put the value of u back again. So u originally was this variable. So the final answer here would be 2 by 3, putting the value of u x cube plus 2 to the power 3 by 2 plus c. So this is the solution for the first question. All the other questions 4, 5 and 6 will also be solved using integration by substitution. The only difference would be here we are going to substitute different things. So here for this integral question 4, you will substitute u as x to the power 4 plus 1, and if you see in each of these questions you're already given the value of u, so it becomes very easy. So let's do this part also here. So this gives you du is equal to 4x cube dx. So you can get the value of dx from here. It is going to be du over 4x cube. Let's put it back in the integral. So the integral changes to, I'm going to write here, x cube is as it is. This is u to the power minus 2 by 3. In place of dx we put du over 4x cube, and now we are going to cancel the common terms and simplify. So x cube is going to go away, 1 by 4, and then integral of u to the power minus 2 by 3 du. Let's apply the power rule for integration. So the power increases by 1, it becomes u to the power minus 2 by 3 plus 1 divided by minus 2 by 3 plus 1. Don't forget the constant of integration. Simplify, so this thing comes out to be 3 by 4 u to the power 1 by 3 plus. Last step, put the value of u back. You had taken u to be x to the power 4 plus 1. Final answer for this question is going to be 3 by 4 x to the power 4 plus 1 to the power 1 by 3 plus c. So that completes question 3 and 4. Let's do 5 and 6 in the next slide. So let's now solve question 5 here using the same method, integration by substitution. U is given to be square root x plus 2, so we take the derivative du by dx. It is going to be same as x to the power 1 by 2 plus 2 here. So when we take the derivative using power rule, it changes to 1 by 2 x to the power minus 1 by 2. Derivative of 2 is 0, so from here we get the value of dx to be 2 square root x du. Now we are going to put this back in the integral in place of dx. So the integral here becomes integral of u cube, and in place of dx you can put 2 square root x du, and in the denominator you also have this. So now let's cancel the common term. This and this is cancelled, so there's going to be 2 integral of u cube du. Let's apply power rule, so this becomes 3 plus 1 over 3 plus 1 plus c. Now we put back the equation, the value of u, so this becomes 2 by 4. U is square root x plus c, and the power becomes 4 plus c. Again, you can simplify, cancel the common term, so the final answer is 1 by 2 square root x plus c whole to the power 4 plus c. I'll just correct this thing. Instead of this c, you have 2 here, so that is the correct answer. So that completes answer number 5. Now we do the last one, which is 6. Here u is taken to be sin x, so take the derivative. Du by dx is going to be cos x, so you can substitute back dx as du over cos x in the integral. So the integral becomes integral of u cos x over du over cos x. Again, we cancel the common term. This is quite simple. Apply the power rule. Integral of u du becomes u square by 2 plus c. Put the value of u back, so it is sin x whole square over 2 plus c. So that's your final answer for this question. I hope you found the video useful and you understood how to integrate functions by using substitutions. This completes today's video. See you in my next video, which is going to be on the next learning objective 5. So stay tuned to my channel. Don't forget to like, share and subscribe. Until then, this is Ms. Ruchika signing off from today's video. See you in my next video. Bye-bye.